How is everyone doing? Let's remove the starting soon banner because we've already started and we couldn't have been more excited for this event, aren't we? So, hello everyone, welcome to the March challenges. We've been hosting these challenges for about a month now, and I can't even believe that it's the 24th day. I'm sure you have learned some amazing things and participating in some interesting challenges while doing so. The coaches were live each day and they've made it this whole month full of so many interesting challenges that you got a chance to build something new every day, and today is another day to build something awesome. We're going to be working on creating a tic-tac-toe game. More about that in a little while, but before we move on to that, there's a lot of stuff that we can do. But I'm live today. So let me first introduce myself. For those of you who don't know, my name is Sashruga Kaur and I am a coach for the APAC region. And for those of you who are joining me again, welcome back. I've missed you, and I know it's been a while since I've been up on stream, but I was working on some interesting projects of my own. And now that I'm back, I could have been more excited to, start again with these challenges. These are so interesting. And let's just dive right into it. But before we do that, what's the first thing that we do, folks, whenever we start with a new challenge? What's the first thing that we do? That's absolutely correct. We check in. For those of you who are joining in just now, check in now at hackp.ac/tic-tac-toe. Hi, Gaurav. Hello, everyone. So yes, Gaurav is absolutely right. We check in as soon as we start with a challenge. And the check-in link for this event is hackp.ac/tic-tac-toe. So just give me a second. I will share my screen and we will do that together. So don't worry at all if you've not done it yet, but let's do it together for this one. All right. Ooh, okay. Okay, so when you head over to Discord, I hope that you're already in our Discord server. If you're not there, just visit discord.mlh.io. Let me put up a quick banner here so that you all can do that. Awesome. So when you head over to discord.mlh.io, this is what it looks like. It's great. You might have to get your roles first by clicking on the get started link and getting yourself a member role before you see all this. But you can see the announcements channel, the March challenges announcement channel, where you'll see the message that I just posted, this beautiful message. And in this message, you can see all the things that we need to do before we start the event. So are you ready for this, folks? So let's start with that. Oops, too much zoomed in. All right. So the first thing that we need to do is check in for the March challenges if you haven't yet. So first things first, if you haven't yet, check in on the March challenges page. And all right. Okay. Okay, looks like I need to share the entire browser. And there you go. So when you visit the March challenges page, you just have to go to hackp.ac/March challenges. And then it'll take you to the page that I am at right now. And you have to click on register and check in for the event to successfully do that. There are tons of other events still available. So if you are joining in right now, make sure you also join us a little later. All right, 1 second. Yes. So when you go to hackp.ac/March challenges, you can check in on the event by clicking on the link here. I've been a great member, as you all know. I always do. I've already registered and checked in for the event, but you can do so as well. And once you are through, we're through with the first step, folks. The first step is check in for the March challenges page, which is like the entire event that we're running, the streams that we are running, and it's super, super, super incredible to see you all participating in such incredible numbers. Next thing that we're going to do is check in for this particular event. We're going to build an amazing tic-tac-toe game. We've all played the tic-tac-toe game right before, and so it was a very interesting game. So I remember I used to play it when I was a kid in school. I mean, who am I kidding? I even play it right now. We use that game as a deciding factor who's going to order the food next, because, it's going to be someone who's going to decide who's going to pay the bill or something like that. But Yes, of course. So tic-tac-toe is an interesting game that I've been playing my whole life, and to recreate that with you all would be so great. So everyone who's joining in just now, the only thing that we have done yet, so don't worry if you've missed on some, if you feel that you've missed out on something, you haven't yet. The only thing that we did for now was check in on hackp.ac/March challenges. So go ahead and do so if you haven't yet registered. The next thing that we're going to do is register on hackp.ac/tic-tac-toe. So let me share my screen one more time and we can do so. So, all right. There you go. So you need to go, all the links are there in the Discord server. So you need to go to discord.mlh.io. You can see that announcement there and you can find all the links if you don't know what they are. But I am actually trying to be very proactive here and telling you all those links as I move forward with them. So the link for today's event is hackp.ac/tic-tac-toe. Once you visit this link, it'll redirect you to a page, which is the MLH live stream page, a create a tic-tac-toe game. And you can see that there is a register and check-in button. Whoopsie, I think I missed out on this one. And I have not yet registered for this. So once you visit the hackp.ac/tic-tac-toe link, which is just down there below, all you need to do is click on register and check in. And as soon as the button turns green, you are already checked in and you can join the event from Twitch where you are right now. So if folks you're joining in from the IST region, I'm sure it's lunchtime for you all. So grab some snacks, sit tight, and I'll guide you through creating a tic-tac-toe game in a while. We'll talk about some wonderful things that we can do. We'll talk about the code base. We'll talk about the step-by-step process on making it happen. And we'll also talk about the improvements of the code, how we can make it better, more readable, more functional, and what else we can do as the next steps. At the end of this event, I would love if you can make a submission on DevPost to show what you coded and what you created for how you created your game. There are endless possibilities. You can create a game which plays with a computer. You can create a game which is a two-player game. You can do wonderful things while creating a tic-tac-toe game. You can keep it as simple as you can and make it to a whole new advanced level if you wanted to. Again, for the sake of this workshop, we'll try to keep it very, very beginner friendly. So in this session, we'll cover the very basics. We'll talk through the code. We'll use Java to code. You can choose any language of your choice, take your pick, whatever your preference you might have. And then we'll move on to some other, improvements. So we'll talk about how we can make the code better. We'll talk about what else we can introduce as well. So now, since we all are checked in, I hope that you all are too. Since you all are checked in, we'll be starting now with the tic-tac-toe challenge. So what we're going to do here today, we're going to recreate the classical tic-tac-toe game. Now, this has been an incredible game that we've all played when we were kids, right? I played round two. I'm sure you all do as well. So if you're playing a tic-tac-toe game, it's a very simple game where it's like crosses and zeros and players take turns to play this game. So if you haven't played it before, it's a simple game where you can put crosses and zeros in a 3x3 matrix form of structure. And what we need to do is win the game by getting 3 in a row. That can be 3 in a row, 3 in a column, 3 in a diagonal, any sort of any way possible. And whoever gets that first wins. So very simple game, and we're going to create this game right now. I'll be using Eclipse. I'll write the code. I'll guide you through the code, which is written in Java. And then we will work on making some improvements, and we'll also talk about how you can introduce other features to it. Post this, we'll also play the game for a little while because it's interesting, and I'll share my screen. So if you are new to coding, like absolutely beginners, you don't know much about a programming language and you're still starting out, this is a great exercise to learn and start with something very basic. The very basic thing for a tic-tac-toe game would be to just build the board, place the pieces, stuff like that. Keep it very simple, keep it very basic. Try to learn that language and try to learn what's the best practice to use that language as well. So with this being said, if you are an experienced hacker who are joining us for this session, this is an incredible and a great opportunity for you to take it above and beyond, right? Learn a new language and try to implement in a language that you haven't done before. So if you know how to code in C++ and Java, let's say, try Ruby on Rails, for example. Try React. Try any other language that you want to. Try Python. But if you want to go ahead and beyond, you can also try out artificial intelligence libraries and make it more smarter. So we're going to talk through the code. We're going to pursue this process. I hope that everyone is checked in. If you are checked in right now in the comment section, give me a thumbs up or give me a yay so that I know you all are ready and you all are checked in, and we can start real quick for another challenge today. And to answer your question, are there any swags and stuff? Jayan, we're here to learn, we're here to have fun, and we're here to enjoy recreating this classical game. I don't think swags and stuff would make up for the fact that that we're trying to learn something new here. All right, so awesome. Everyone's checked in, and I love to see it. Love to see your enthusiasm, folks. I mean, I have been away from the stream for a while now, but I'm super excited to be back with you all because I've missed you all, and you folks have been incredible and amazing. The last time we did like 3 hour long streams during local hack day build was kind of my favorite time because we used to hang out like all day and learn something new, finish challenges, and then earn points for our guilds. I mean, that was super interesting. Speaking of which, speaking of local hack day build, we also have local hack day share coming right up next week. And there's tons of interesting streams, mini events, workshops, sessions, guild challenges available for you all. So stay tuned for that. If you haven't registered yet, you can go to localhackday.mlh.io and register right now for local hack day share. The sessions are up. The schedule is also being uploaded as we speak, and you can also find out more about what is there in store for you for local hack day share. It's going to be an interesting event. Remember the time when we had a lot of fun at local hack day build? Well, local hack day share is going to be a level up, and it's going to have so many interesting events for you all. We had such an incredible time planning these interesting events for you, and I am absolutely sure. I'm 110% sure that you're gonna have as much fun enjoying. You'll enjoy as much, working through those challenges and earning points for your guilds. So if you've not joined a guild yet, make sure you do so. There's so many interesting guilds out there. I, for one, I'm not sure which one I would want to join. I mean, I'm kind of a little inclined towards the Blahash gang because, of course, it's Jack, and I really, really appreciate Jack's support. She loves Bahaj, and right now when I'm choosing that guild, I'm kind of inclined towards choosing that, but let's see which one I go to. So if you haven't registered yet, make sure you visit localhackday.mlh.io, and somebody asks for the link. Yes, of course, I can post that for you all in the comment section so that it's easier for you to get it. Wait. There you go. So the link is also there in the comment section. It's up here on the stream if you are still looking for it. So it's localhackday.mlh.io. You can visit this link. It has you can see all the interesting events that we're planned, and it's next week. So I'm super excited for it, and I hope that you are too. Now, all right. Let's see. Okay, I think the link is not working for some reason. Let me quickly check if it's. I hope that it's fine. I mean, it should be. All right. So this should be fine. And please make sure that you do register for it and join us next week. All right. So now that we are through with this entire checking up on each other thing, I'm sure that you all had a great month and you had a great time enjoying these March challenges. So let's start with what we are here to do today, right? We are here to create a tic-tac-toe game, as I said. And for those of you folks who are joining us now, make sure that you do check in on this link, hackp.ac/tic-tac-toe, and we're going to start real soon. So let me just quickly share my screen, and then we will start with this. All right. Let's see what do we have here. Okay. Cool. All right. So I'm sharing my screen, and let me know if you can see it, and then I'll guide you through the code. Okay. Let's see. All right, so screen should be visible. Let me get rid of this banner. And all right, I think we're all set up. So before we start, make sure that you follow along, make sure that you have your own IDs ready, like whatever ID you're comfortable with. I'm using Eclipse. You can use whatever you want. You can use IntelliJ if you will, like you can use Sublime, but you might want to use command prompt to run the code. Any IDE or text editor you're comfortable with, you can use that to write the code. It's very simple, and I'm going to guide you through all of it. The thing that we need to take care about, while creating a tic-tac-toe game is we want to break this entire project into simple, small chunks. And once we do that, it's going to sound really easy and really simple for you to recreate this game. Because it's the thing about tic-tac-toe is once you learn how to create a tic-tac-toe game, the other games, the other simple ones, if you want to recreate them, they might not seem like such a tedious and big task because we're starting from the basics. We learn how to break the code into chunks. We learn how to write that code while breaking them into chunks, and then we'll move on to talk about how you can expand it. And instead of a tic-tac-toe game, if you want to create, let's say, a snakes game, I mean, that is also pretty simple. You can use C++, Java to create a snakes game as well. So there are a lot of other games out there that you can try your hand at. I mean, I, for one, think that tic-tac-toe is a great way to get started with it, learn the basics, tweak a little with the code if you want to try something new, and take care of the edge cases, of course. So we're going to look at the code here. We're going to browse to the code, give it a code review, talk about different assumptions that folks have, and how you can write more readable and more defined code. We'll also talk about if you're just starting out and you're just new to all the space. I mean, I've tried to keep it very simple and stick to the basics, but if we also talk about how you can take it a level up, how you can implement those OOPS concepts that you've just learned to this project, and how you can break your code into chunks and pieces, write different functions for different functionalities that we want to introduce, or different features that we want to introduce to our code, and then move on from that. It's going to be an exciting one. So for those of you folks who are joining in from around the world, I'm not sure where everyone is joining from. Why don't you just let me know in the comment section? So type in right now where you're joining in from, because I, for one, am joining in from the IST region, and right now it's practically lunchtime. So if you are joining from the IST region as well, don't worry, grab your lunch, sit tight, code along with me, and let's have a great time working through the code for a tic-tac-toe game together. So type in the comment section and let me know where you're joining in from, the zone you're joining in from. I'm super excited to see you all. I hope to see the familiar faces that I always see up on stream. So Gaurav is joining from India. Hey Gaurav, a big shout out to you. And before we start with the tic-tac-toe game, I hope you all are ready. So open up your basically IDs, open up your IDs, whichever one you're comfortable with. And of course, whichever language you're comfortable with. So if you don't know Java, don't worry about it. The basic fundamentals, the beauty of the project is that the basic fundamentals remains the same. So whichever language that you want to do it, I'll explain what this the Java code does, and you can re-implement it in your own language. For example, if you're doing C++ and I say that print the statement, you know how to print a statement in C++, so you just do that and change the syntax for the code, right? So whatever that might be, whatever language you prefer, just don't worry about it, and you can I'll guide you through the code and you can write about it. Hi Utkarsh. Utkarsh is a familiar face. I've seen Utkarsh around quite a lot of challenges, and as in the local hack day build stream. I hope you're joining in local hack day share. I'll see you there. So everyone, if you're joining in right now, make sure you do check in at hackp.ac/tic-tac-toe before you start with the event. We are here on Twitch and we'll be live for quite some time, and I'm going to guide you through the code, and we're going to work on creating this game together. So I hope that you're all settled down. So let's start with this particular sections first. So as you can see that this is a pretty basic code, and we've already seen that I've divided it into a few functions. So you can see that there is a main function, there's a play tic-tac-toe game function, then there's a valid position, print board, place piece, and a check win. You don't have to worry about all of this. The only part of code that we're going to focus for now would be the play tic-tac-toe game. Think about it this way. Now, the first thing that you want to do is give your users a functionality to, play the tic-tac-toe game when they enter your process. Now, right now, I'm implementing this purely on console, but you can implement it in an application as well, and then, make this game actually make this game in an application, implement it in a website, do anything you want to do with that. So let's say whenever they click on a button, the play tic-tac-toe function is initialized. Right now, we'll just call the play tic-tac-toe function in the main section. We'll talk about the main function, we'll talk about the main function a little later, the code that we wrote in that. We'll talk about the play tic-tac-toe right now. So let's open this up and see what do we have here. All right, so the first things first is that we want to start with printing the game board, right? So what that means is our board, as I said before, looks like a 3x3 matrix. So if you haven't played a tic-tac-toe game before, it's pretty easy. All you need is a 3x3 matrix like this. And let's just, what we can do is just print the board for a second. And I'll show you how the board really looks. So it'll give you a better idea. Right. Let's run this code and see what the board right now looks like, and then I'll explain how to create this board, right? Okay. And there you go. Oops, I think there is something wrong with the code. Give me a second, let's see. Okay, it's a compilation error, which means it's somewhere. Okay, great chance for us to debug. Let's see what's wrong with the code. Okay, I should have seen which line it was in. Give me a second. Let's run this again and see which line it was in. All right, so as we can see that there was an exception, which means that there's an unresolved compilation error at line number 14. Let's see what we have at line number 14. All right, it is right here. Okay. Seems like a bracket problem to me right now. Let's see. Yeah, so. Okay, so. Oh, I see. Okay, wait, 1 second, please. Let me just. Play. Yeah, it was a bracket problem after all. All right, so let's try this once again. Oops. Let's see. Yeah. So the error is solved. So I commented a bit of the code, and there was a bracket problem because the while bracket, since I commented it out, it was still open below, right? No worries, we fixed that. Let's try it one more time. Okay. Okay, so as you can see, this is what a board looks like, a tic-tac-toe board, simple 3x3 matrix, right? And in this 3x3 board, you can see that, if you want to place an X or let's say an O, you can place it on either of the boxes. So what we did right here was just create a simple matrix, a character matrix, and we created this board because, presentation is also important, right? So we just being creative a little. So I'm following a tutorial. You can also follow another tutorial online if you find, if you like a different one. But this is what your board looks like, right? How to create this board? Very simple, very easy. Let's look at how we created this board. Okay, so to create this board first, let's see what we have here. Okay, so we wanted a 3x3 matrix. Am I correct? Absolutely. So to create that 3x3 matrix, what you need is 3 blank spaces. So first blank space, second blank space, and third blank space. We all need to replace this with X and O's as soon as someone places a piece or takes a chance. To create this board and to actually have that aesthetic phase where you have created some boundaries, what I did was I just introduced a line in between, another one here, and then another. We also tried to create a boundary here, in which we introduced another row. So this matrix turned out to be a 5x5 matrix in order to create the boundaries as well. So very simple. I hope this particular section is clear. All I did was created a char 2D array, 2D matrix. And in that 2D matrix, what I need 3 spaces where I can actually place a piece. And at all the other point, I'm just creating boundaries. So there's one boundary like this, one boundary like this, as you can see, this one. And then also 2 boundaries are the same way, which is an additional row that we added right there. Then this is another print board function. We'll talk about the print board function in a while, but this is simply printing the entire 2D matrix to actually show you what's there, what's placed, and what's not placed, and how your board currently looks at any point in time, right? So we'll talk about the print board function a little later. It's pretty simple, but for now, let's focus on what code we're trying to write here, right? So first off, we want the user to play. Am I correct? Absolutely. So we want the user to play, and then we want the computer to play. So if you want the user to play, first off, we need the input from the user, right? In order to get input from the user in Java, we can use the scanner class. So here, for first things first, what I did was create a scanner class with an SCN object. So this is an object created from the scanner class, and we gave it a system.in argument in order to, take an input from the user. So we want to take an input from the user. So first off, we print on the console that where do you want to place X, enter the position. If prompting the user to, enter a position, we also mention what type of input are we expecting there. So they can type in at any input. Like for example, for the purpose of this particular session, I've used the terms from 1 to 9, which means that what my game board looks like is this position is place 1, this is place 2, this another one is place 3, then come down here, this is place 4, then so on 5, 6, and 7, right? So this is how my board looks like up until 9, right? So if they're entering a position, this basically means that I want to place my user piece at that position. I've hard coded it that the user would always get an X as a piece, but you can also take that as an input from the user first. You can ask them what piece you want to play with. Do you want an X or a no? I mean, pretty easy, right? It's very simple projection. We'll just ask the user to give a prompt here in the similar way we are asking them to, give an input here using the SCN class, using scanner class. So with the SCN object, we do an SCN next int, and we can ask the user to choose if they want an X and an O, the same way that we're asking them to input the position. So this is another thing which I've not implemented yet, but this is something that you definitely should try, right? All right, so let's talk about what's next. So we took an input from the user. Right now, this is what's happening. We took an input from the user, and now we have to place the piece on the board, right? So let's just focus on this first, right? So we have to place the piece on the board, right? So we took the input from the user, we're placing the piece on the board. So this is another place piece function. Let's just say, we're not going into the function right now. Let's just say that this is a place piece function, which is already written, which you already have. You can use this to place the piece on the board. So what we're trying to tell the place piece function is that I'll give you your board, I'll give you the number, the position where you want to place the piece, and I'll tell you which user is actually playing, if it's a player or if it's the CPU. Whoever is playing, all you need to do is place the piece. So right now, in this particular 3-line code, what we're doing is we ask the input from the user where they want to place the piece, and with the place piece function, we actually place it. It's a very simple, very easy part where you're just asking for an input and then placing the piece. So the part of code that I actually deleted was to actually check if it's a valid position or not. Now let's say that the position is already taken. So in order to do that, let's first run the tic-tac-toe game for a few minutes, and then we can try out and tweak with the code, right? So let's say this is your board. Now the program is asking where do you want to place an X, right? Enter position 1 to 9. So which position do you want me to enter, folks? If you don't have anything in mind, I'll go ahead and take my pick. All right, let's say we place it on 5 for now, right? So as you can see that I placed it on 5. Oh, Gaurav, you and I think a lot alike. Gaurav also said 5 and I took 5 as an option. So cool. All right, so we placed it on 5. Now the computer placed it at position 8. Right, next up, we want to place it at a different position. So let's say, what if we go ahead, let's play a successful game for once. So what if we aim to win, right? Let's place it on 9. Now still we are in the winning position. The only thing that we need to do is place it on 1 because the computer was silly enough to place it at number 7, which means that we are probably going to win this game. So yay, we won. Congratulations. All right. So now let's just say we want to place the X piece again, right? Now to place that X piece again, we want to enter another position. To enter that position, we'll choose a number between 1 to 9. Very simple. Let's say we choose 5 again. the computer again placed it at 8. So now we want to place it at another position. Let's say we place it at 8 again. Now 8 is already taken by the computer. It should give us an error, right? And that is what it does. So it tells us that the position is already taken and that we should try another position. So now, right now, Atul's Thomas said that we should place it on 7. So let's just try that. Let's place it on 7. There you go. We can easily place it on 7. And now in order to win, we need to place it on 3. But let's say we go a little easy and we want the computer to win, right? So what if I place it on 1? Ooh, now I think I'm actually winning this game. Or we can just go ahead with a tie. So let's see if we can go ahead with a tie because we already won twice. Right. So nope, looks like we're gonna win this game. And there you go. We won. Oh, it's a tie. So you see, we found something wrong with the code, right? We'll fix that in a bit and I'll show you how to fix that. So you can see we already won the game, but it still shows us that it's a tie. Now I figured out what's wrong with the code, but right now, let's just ignore that for a bit and we'll use this as an exercise once I do the entire code review for you to figure out what was wrong with the code. Cool? All right. So let's just say, all right, we don't want to play again. Thank you so much. And we're done. Cool. So don't worry about the it's a tie thing right now. We'll fix that problem together with the code once we're through with the review. But for now, let's just focus on this valid position. So we were checking for the valid position, right, which was a user position, to check if it was a user position, is a valid position or not, which means that the position should not already be taken, and then we place the position, right? So let's not go into the valid position code for now. We'll just focus on the whole chunk of it, and then we'll break into big pieces. So as you can see, what we did first, to do a quick recap until now, we created the board. We have a different function. We broke it into a chunk. We have a different function for the print board feature. Next, we also have an entirely different function to check if it's a valid position or not. And then we also have an entirely different function to place piece. So as you can see, our play tic-tac-toe game remains very simple. You have the board, you take the input, you place the piece, and you check if it's a win. Rest all the other all the other features that we're trying to implement, basically checking the valid position, placing the piece, checking if it's a win or not. All of these positions have a different function altogether. So we'll work through these different functions, but for now, let's just focus on this. So let's say if we placed a piece, right? Now it's our chance to just, right now, what we'll do is we'll ignore the check thing right now, and we'll focus on this particular section of code. So there are two functions that you see right now here, right? There are three actually. There's also print board. So there's print board, there's valid position, and there's place piece. Let's see what's there in each of them. All right, before we move on to the next. So let's see what's there in the print board. So this is another code that we wrote in which we are just printing the board. So I send the character board, and right now this is like a character 2D matrix. So don't think of it as a board right now. Think of it as a 2D matrix which we're trying to print. How you'll print that? Of course, you'll use the for loops. So there are two loops that we're using here. It's a row. First loop is the row loop. We're using an enhanced for loop. You can use the for I. If you're learning, you probably start with the iterative one, the int I equals to 0 and stuff. Anyhow, all you need to do is print that particular section. So if we're trying to print a character, print that character, and then print the next line. So this is basically printing the board. Very simple, practically easy code. So I'm not going to go too much into this. If you're starting out, this is something which you can probably learn because it's very simple. There are two for loops, and we are just printing the matrix one by one. Okay, all right. So let's just focus on, this is the part of the code where we have our valid position. So right now, let's say that we are the user is trying to place it at a position where the position is already taken, and we want to implement that feature. So you want to check if it's a valid position or not. So we do go to this valid position, and we check if that position is occupied or not. In order to do that, we have like a list of all the positions that we have placed, and we have a list of all the CPU positions that are placed, and we check if our position is in either or of those, and we just return a simple true or false basically. Don't worry if this particular function of code is not created now. As soon as we finish up with place piece, you can put all of these together and you'll understand how this entire code base works, right? So if this is not very clear right now, just let's think of it this way, that there's a set of player positions, there's a set of CPU positions, and if it's not in either of those, that means that it's false. That means it's That means it's true. That means it's a valid position. Else we'll return a false, which means that it is not a valid position because one of the or the other actually has this particular position that we are trying to place. Like some piece is already there on the board, right? So coming back up, let's talk about the place piece. Okay, all right. Before we talk about the place piece or the check win thing, let's see if we can also implement the CPU code, right? Very simple. So folks, before we focus on this particular section or before we focus on the CPU part of it, let's just do a quick recap of what we did and how we did it. Easy? Right. So what did we did with the user plays? We ask the user's input, we check if it's a valid position or not, and then we place the piece, right? 3 steps, everyone following along. 3 steps, right? First, get the position from the user. Second, check if it's a valid position or not, and then actually place the piece. Cool? 3 steps, simple. That's the same thing that we want to do with the CPU, right? We want the CPU to actually choose a number, tell us what the number is, and then we'll place the piece, right? 3 steps. We'll check, we'll ask the CPU to choose the number, tell us what the number is, we'll check if it's a valid position or not, and then we'll place the piece. So it's practically same. Now, I know that you can write it on your own, so I'll do a quick code review for you all, but try it out. I'll wait for just a quick second. I'm talking about the code. Just try out and write this particular section down. All right, just write the steps, if not, nothing else. How will you re-implement this to create the CPU code? So let's say if you want the CPU, if you want the CPU number, let's say that the CPU position is stored in a CPU pos variable. So there's a CPU, there's a user position variable, there's a CPU position variable. You get the CPU position there. So in order to re-implement this, what you'll do is you'll send it to the valid position code, valid position function. You'll check if it's a valid position or not. If it's not a valid position, you'll just get another input. And finally, you'll place piece. So for place piece, when CPU is actually working, we'll send the board, we'll send the CPU position, and we'll tell the place piece function that the CPU is playing. So instead of player, we'll write CPU, right? So let's just quickly see what is here. Right. So again, you can obviously use artificial intelligence, you can use other things, you can make this code more smarter when you're trying to write this. I'm going to use randomizer here, keep it very simple, but this is a section which you can play around to see if you can make smart moves, right? So again, we're using the randomizer to generate random CPU moves, and right now the CPU position, we want the branch next int, we want this function to give us the random integer. Now, this rand.nextInt function is basically demands for an upper bound. So right now with the upper bound we want to provide them is 9, because what it does is it gives us a random number from 0 to 9. And since we want a number 0 to 8, 9 is like the upper bound. So if we want the number to be from 1 to 9, we would just quickly add a 1 to it, and it will just shift the range by 1. So that's the same thing that we want to do. And again, first we get the CPU input. Next, we check if it's a valid CPU position or not. And then if it's not a valid position, we just keep on getting that random integer again and again up until we have valid position. Once again, we place the piece and print the board. So place the piece has the board, the CPU position. We send the CPU position. We tell him that the user right now, the user that is playing is CPU, and then we print the board. So this part, I hope that this section is really, really easy and simple for you. So if you have any questions, please do ask now, and then we'll move on to the place piece code. We'll see what is there. We'll see how we can make changes to it. And then we'll come back to, we'll come back and review this entire section together. Then we'll move on to the check-in function. So this is what the whole session would look like. But for now, I want you to tell me if you do have any questions at all, right? Now, let's work on the place piece code together, right? So this particular part, up until this, it's clear. Again, user position, valid position, place piece. CPU position, which we want from a random integer, valid position, place piece, right? So if you want to place piece now for the player or the CPU, let's see what the place piece function looks like. Now, I'm practically, making it very simple for you. So if you're trying to learn out of the language, this is one of the basic things that you see when you say learning Java or any other programming language, is that it's the switch case. So So you learn about for loop, you also learn about the switch case. In the switch case, basically any position that we want to map it to, that place in the matrix. Yes, so Gaurav has a great, brilliant question, which is random position from should be from 0 to 8. So how 9? Now, Gaurav, see, what we want in our entire matrix is that we want the numbers from 1 to 9, right? The upper bound for the random function, the random function basically asks for an upper bound. It starts from 0, and the upper bound, they ask us to give an upper bound. So right now, the upper bound that we are providing is 9, right? Which means that the number that the random integer would generate would be from 0 to 8, right? And if it will generate a 0 to 8 number, the only thing that you need to do to shift that range would be to add 1. So if you add 1 to it, from 0 to 8, the range is shifted from 1 to 9. Does that make sense? Let's see if it, I'll just implement this for you to see if you get that. So what the random integer does is generate a number from 0 to 8, right? This is the range. Now, because the upper bound was 9, which means that the number should be less than 9, greater than 0. Of course, it's a random number, so it should be greater than 0, and it should be less than 9, right? Whatever number that we want to enter, which means that it should be from greater than equal to 0 and less than 9, which would be from 0 to 8. We are adding 1 to this entire segment, right? So what I'll do is, it'll shift our entire range from 1 and from here it'll shift to 9, which is exactly what we wanted for our code all along, isn't it? So let me know if it's clear. If not, we'll just go over it one more time to see if it makes more sense. Awesome. Glad that you got it. If you have any questions, feel free to ask them anytime in the chat section, and I will be happy to take them up for you. All right, so now the random integer part is clear. Now just creating a random integer for the CPU position, checking if it's a valid position or not, and then placing the piece in the board. Now, in order to keep track of all the positions that are happening, so the player is playing some position, let's say the player plays 1, 3, 5, 9, whatever position the player is playing, and the CPU is playing at the same time, 2, 4, 6, whatever the position the CPU is playing. Now, all of these positions, we need to keep track of these positions, right? In order to do so, we'll use a very simple, very, very simple thing here for this code, but you can use something different as well to reduce the complexity. Right now, I'm using an array list. So I created a static array list for the player positions and the CPU positions. Now, the reason that I'm creating an array list is because I want to implement this as sets and see that if this particular set actually contains the player position or not, and if the other particular set actually contains the CPU position or not, right? So we want to work through that, and that is the reason that I used array list. You can obviously use hash map, hash set, different, you can use something different to actually reduce the complexity. But this is what we're going to work with for now. You can also obviously change that. So now I think some of it makes a little more sense. Now, if you remember in the valid position section, valid position code, we actually saw that the player positions and the CPU positions actually checked if it contains the position that we want to place our piece at or not. So in order to see if the player position or the CPU position actually contains that position, we just send that position to this code, and then in our array list, we use the contains function, which is like a sets thing, the set thing, where because the array list is implemented from collections class. So that is why we can imagine it in that way, and we can use that functionality for that. So we will check if actually the array list contains the position or not, right? So this is what this code says. So this code will be making sense right now, as of now, and the upper part could also be clear to you. I hope that it is. Awesome. If not, feel free to stop me at any time and ask questions, because I'm trying to go through the entire code because I want to cover a lot more in this place, and want to try debugging the code to fix a few problems that we already saw with the code. For example, the tie feature, the other things, or improvements. There is a lot of content that we want to cover with the tic-tac-toe game, and that is why I'm trying to keep it very short and crisp and give you the entire content that we want. So I am super glad that you are following along and that you're enjoying this. But if you do have any questions, feel free to stop me at any time, right? So I hope that this all makes sense. So right now, remember, okay, let's do a quick order recap right now to see if we have everything in place, right? We have everything in place or not. So what we did was we asked the user for the position. We checked if it is a valid position or not. So it goes into the valid position section and sees if the position is correct, which is by actually checking it if our position is not already occupied by being in one of the array lists, either in the player position array list or the CPU position array list. And the next thing that we did was actually place the piece on the board. So now we'll work through we work to another segment of this code, which is place piece, and we will work, our way through it. So we'll make it more generic so that even if any user that is playing, we just need to know which user is playing, and we can, work our way through the code again. But more or less, right now, this is what the entire segment looks like. So don't worry if something is still not clear for now. We'll work through the place piece function right now, and then we'll go through the entire segment of code again to see what is happening and where it is happening. And then we'll move on to try and fix some of the things that we know that are wrong with the code. Cool. So let's see the place piece segment. Right now, we wanted to place the piece on the board. So first of all, we need the board, right? The second thing that we wanted to do was know which position we want to place the piece in, which could be either from 1 to 9. So whatever that may be, we have the position. Next up, we want to know which user is placing the position. Remember that I told you that in this particular code base, we by default selected that the player who's playing the game would get an X, and the other user, if the CPU is playing, will get an O, right? You can obviously change that, but right now we selected that. So this user is basically, this user section basically, this user argument basically helps us define whether the player is playing or the CPU is playing, and which piece should be assigned to that particular character, right? So it's a character matrix. We want to assign an X or an O, depends on which user is playing. So everything here actually makes a lot of sense when you start writing the code. So if you're writing the code and we are breaking it down into segments, you'll see why we need a particular thing, why and what we need a particular thing. So the thing about writing code in Java or in any other language, or if you're developing as per se, is once you move on and actually work through your code, you realize that this is something else that we need, and this is probably something that we need as an argument. So we'll ask the main function to send it to us, or we'll just figure out in the code. So whatever piece fits, wherever piece fits. So right now, the reason that I'm breaking it into chunks is actually like talking through the code and working through it is because I want you to all to understand that whenever you're writing your main code, so whenever you're starting with a new application, just a quick tip there, just break it down into a chunk of pieces. See what you need to do and just comment it out and write it out. Whenever you don't know what to do, just create a function. How to create a function? Just write that this function is to be created, like for example, whatever name it is, and let the error stay there for a while. But right now, just create an overall draft on what you want to do with your application, and then implement those functions separately. It'll make your life and your code a lot easier to read and a lot more easier to understand. So if you want to go back and make changes to it, it's practically very simple to update it and make changes to it. So I hope this tip helps, but let's move on to the next segment. All right. So the place piece. Now we have a piece. Like right now, the piece is blank. We have to check if we have the user is a player or a CPU, and then see what basically we want to place. We want to place an X or a no. So if the user equals to player, so equals is basically we need to check if the string is player or the string is CPU. So again, be very aware. We are using strings here, which means that you cannot do a simple equal to actually check if it's a player or not. You need to use the equals function in order to match the strings. So if player is there and CPU is there, so let's say if player is there, we're going to place the piece X and add it to the player positions array list. If CPU is there, we're going to place the piece O and add the position to CPU positions. So I think this particular segment is very much clear, where we were just checking if it's a player or if it's a CPU, and then we're just matching the piece with it. So we're reinitializing the piece with an X or a no, depending on which user is playing, and we're adding that position into our array list to make sure that it's occupied. It's already done. It's occupied. You cannot place the position again. So when we go up and see the valid position, so when someone actually goes to the valid position function and checks if it's a position or not, it will already contain the position that is occupied, right? So I mean, this two segments would actually make sense now, because right now we are placing the piece and we're also checking it in the valid position segment. So these two pieces would make a lot of sense now, because we what we did here was we select what piece was it, we added it to the array list, and from the valid position function we're actually checking if whatever position we're applying to next is already in the array list or not. Right, everyone following along? So this part is absolutely easy, pretty simple, pretty straightforward for you all. You can write it in your own form if you want to, tweak a little and try out something different. But this is very, very simple, where you can see. You can also keep a check here, because, in order to incorporate a base case, is that when string user is not a player or a CPU, what then? Right now, we hard coded it into a player or a CPU. If you're making a two-player game, then that would probably be a name, and that name should be saved somewhere. So there are tons of scope of this. The scope of this project is huge. So we're starting with the basics, but this is actually a structure on which you can build upon and make it a little more better. You can try out something different. If you're making this into a two-player game, the user here could be player one, player two, or it could actually be actual names of folks who applied. You ask that function. You can add that functionality too. So whatever you want to add, the best part about this piece of code would be you've already broken it down into chunks. So if you've achieved the basics, any implementation which you want to do on top of that would not be difficult, because then you're going step by step, right? You're taking one step, you're implementing that, then you're trying out another feature. If you're using a different function altogether, you create a different function and you don't touch your code, which means that your code very rarely would break. It would be just implementing a different feature, and it would be contained to that particular section. So this is something which is very incredible that you would learn while developing new applications, because this is a very helpful tip, is what I believe. Now we already have which piece we want to place. We already have the positions. We have to check. We use the basic switch. Sorry about that. Yeah. We use the basic switch case to actually place the position and the variable, right? Okay. All right. So let's see what we have here. Before we move on to the segment, let me explain what is happening here so that it's easier for you to understand. So let's create the board once more, right? Let's do that. Right. So we are creating the board once more. What our board looks like: 1, 2, 3. And then we have 4, 5, 6. And then we have 7, 8, 9. Everyone following along, this is what your board looks like, right? So if you want to place, let's say your position is 5, where you want to place an X. So what we need to do is we need to actually replace that 5 with an X, right? And let's say if we want to place it in position, the computer decided to place it at position 9, the 9 part should be replaced with a 0. Now, let's just quickly go back up here and bring our original board right down. Right. So, and see how we're going to implement that. So right now, this part should be clear. We have to place a piece, and in order to place that piece, we are given a number. We just have to replace that number with the character, whether it's an X or no, whatever that character might be. So very simple and very easy part. Now, right now, we have to replace our number with the character. So what our matrix looks like? Our matrix looks like this, right? Let's move this part and see what our board actually looks like. So this is how your board looks like right now, right? And these segments are 1, 2, 3, and then we also have a 4 here. So bear with me for a second, because I'm trying to explain something for you. It will be easier for you to debug the code when we're trying to solve problems, right? 7, then 8, and then 9. So let's say we wanted to place a position. At position 9, we wanted to place an X, right? So what we need to do is at position 9, we have to place an X. So what your matrix looks like now, you have to map these positions with your matrix, right? So let's see. This is 0, 0th row. This is first row. This is second row, third row, fourth row. Everyone, are you following along? Still, if you're tired, just grab a bottle of water, drink some water, if you want, and it's lunch, dinner, whatever time what is in your time zone, just grab something to eat and then refresh back up, because we are here in a very important part of the segment. The only thing that is left for this particular segment is understanding this piece of code, and then we'll be through with the place position. And all of this code would actually start to make sense. So when you're trying to re-implement this and then make your submissions, it'll be very easy, because then it'll come back to you altogether. If you want, the stream after the stream ends, this particular video would be live, so you can always go back and see what you missed, what else you want to implement, what you tried out. So if you are worried about missing something out, don't worry, just be here, be present here, and if you have any questions, do ask them in the comment section. Right, so 0 1 oops 1 2 3 4. So as you can see that this was a 5 cross 5 matrix, and what it looks like is that there's 0 to 4 columns and then 0 to 4 rows. So if you want to place an X at, let's say, an O at first position, then that means you place it at 0, 0. Right, if you want to place it at fifth position, then you're going to place it at 2, 2. So you see the board is filling up, and the board is populating up with X's and zeros based on whatever segment you want to apply it to. So 5 would be represented as 2, 2. 1 is represented as, the first position is represented as 0, 0. The second position, 0, 2. So as you can see that this matrix, I'll keep this matrix here for now, so that if you want, you can refer to it. So the position here is just a simple switch case where, the case 1, 2, 3, all the cases are then mapped to their respective board positions. So the case 1 is board 0.0, right? So on board 0.0, we just place the piece. If the case is 2, we place the piece. Remember, for a switch case, it is absolutely important to implement the break, because if you'll not do that, whichever case it'll satisfy the first time, it'll just implement all of it, and the board would be populated after that. So if that is a mistake that you're making in your code, this is how you need to fix it. All right, cool. Everyone, are you still following along? Are you there? Do you have any doubts, any questions? Please mention that in the chat room. Everyone, so right now in the comment section, is this point clear up until here? I'll just go through the switch case once in order to see that everyone is following along, and then we can move on to the next segment. It's a very important segment, and then we have to work on fixing some tweaks with the code, and we'll do that together. All right, so if you have any questions right now, please do ask them. So absolutely, yes, clear. Great, awesome. I am super excited to see you all and I'm super excited to see your enthusiasm. All right, so since this section was clear, as you can see, the 0th position has the piece placed, then the second position, the fourth, then 2, 0, 2, 2, 2, 4, and 4, 0, 4, 2, 4, 4. In order to be very clear with that, let's just, yes, of course. So Mohit here, I will repeat it absolutely. So again, have a look at the board. The board has positions on a 3 cross 3 matrix, but we created a board which is a 5 cross 5 board. And the reason we did that was in order to create a boundary, right? So this right here is a boundary. This is another boundary, this one. So basically we created a boundary like this, and we created another one like this and this. So that's just creation of the board, right? So the occupied elements would be 1, or right now basically it's like 1, 2, 3, 4, 5, 6, and 9. 7, 8, and 9. So you can see 1, 2, 3. Then you can see here we have 4, 5, 6, and you can see here we have 7, 8, 9, right? So we have 1, 2, 3, 4, 5, 6, and 7, 8, 9. Now, if you want to place a position at a position, let's say 9, you want to place X because the player was the player was the user right now. So that means that the piece would be X. So 9, which is what? 4, 4, right? Mohit, can you also chat with me in the comment section so that I know that you're following along. I'm following along right now. So the position 9 would be 4, 4 in this matrix, right? And so if you want to place an X at the 9th position, the 4, 4 would be replaced by an X, right? Absolutely. So basically, if we send a position in our switch case, then it'll straight away go to case, it'll just follow and check. It'll go to case 9. The case 9 would be where board 4, 4 would place the piece, right? That's what we did. We have the 4, 4 right here, and we placed an X on that position. Absolutely. Now let's try it with a different thing. For example, the computer is playing. So what will come here is computer will have, let's say, a position 5. Board is already the same board that we have right now. This is what your board looks like. The user would be CPU. It'll come here, it'll see that the user is equal to CPU, which means that the piece is O. and it adds it to the CPU position array list, and then it'll come here, it'll say the position is 5, it'll go to case 5, which means that on 2 comma 2 we place a piece. So this is 2 and this is 2, which means that 2 comma 2 is again position 5. Absolutely right. Just replace it with a no. Does that sound good? Is it clear now? I can try and give another iteration if you are still confused on this particular segment. Let me know, everyone. So Gaurav, I think Gaurav and Atul are clear. Mohit. So wonderful. All right. So if you do have any questions, let me know and I'll repeat this particular segment again. But for now, all the other cases are defined. Case 1 is defined, case 2 is defined, 3. So 0, 0 has the piece position on case 1, then 0, 2. So you can see position 1, 0, 0. Position 2, 0, 2. Position 4, 0, 3, 0, 4. Then here, position number 4 is 2, 0. Then 2, 2, fifth one. The sixth position is 2, 4. Seventh position, 4, 0. Eighth position, 4, 2. And then finally, the ninth position was 4, 4. And that is what we did here. Very simple, very easy. You don't have to worry too much about it. Just think of it on a straight line. So the case 1, 0, 0, we place the piece. We break out of the loop. Because we're only placing one piece at a time, we have to break out of each loop. Else, everything would be, the pieces would be placed at all other places. And it would basically ruin your code. You can try out. I mean, I'm not going to remove all the breaks and show you what will happen next, but if you want, you can try out with your own code and you'll see what happens and you'll understand what I'm trying to tell you here. So basically 0, 0, 0, 2, 0, 4, everywhere, you can just place a piece, right? And then default, you can obviously send a break. So it's very simple. Let's come back up and see what was happening here. So now it will make a lot of sense to you because now we are already putting the pieces together and seeing what is what's happening next. So we have the user position input from we ask the user to give an input. We store it in the user position. We check if it's a valid position or not by actually checking the array lists that we created to see, if the position is present in either the player array list or the CPU array list. And if it is present in the user position array list, then if it is present in either of both of the array lists, we just ask them to send in the position. So right now, the only thing that we're trying to achieve here, if this position is taken or not. Can you tell me what is the other thing that is missing from this code? So in the valid position code, we're actually checking if the player position is there or not. The CPU position, the position is there or not. There is one other thing that you can add to check if it's a valid position or not. Can you brainstorm it on a little? Anyone? Do you have an answer on what position would also be a valid position? If, for example, the user enters a garbage value, what check would you add here in order to ensure that we can take care of that case? So this is what we're doing here. We're working through the code and we are debugging side by side. We are actually working on the bits and pieces together. So we're taking all of this forward. Yes, if the position is null, absolutely correct. If the position is null, if the position is not between the 0 to 9 range, right? If any of these cases are valid, then that means that it's not a valid position. So that is another thing that you can add here. If the position is not between 0 or 9, then that means that that position is invalid. Right now, we are making sure that we are entering the correct position, but we cannot check if it's valid or not. So if how we can check it is valid is just add another segment here, which would be that the pos should be greater than or equal to 0. And another thing that you can add is that the pos should be less than 9, which basically means that it's in range or not. So I'm not adding this right now, but you can absolutely add it and mark that. So it's just, not greater than equal to 0. Pos should be greater than 0 and less than equal to 9 because we're keeping positions from 1 to 9. So yes, Turkey, absolutely correct. You can give an equality sign to 1 as well. So basically defining a range here would be the best way to actually check if the valid position the input is correct or not. So this is how you take care of garbage values as well whenever you're taking an input for the user, because you have to think of the corner cases and you have to think of some of the variables which are absolutely incorrect. So some of these ranges which are absolutely incorrect and basically breaks your code because the input values were not right. Right. So you can try out, you can add this. Right now I'm not adding it here, but you can obviously try out this, because then the reason that you need to add that. So let's say if you're playing with 2 players, right? If you're playing a multiplayer game, then this particular segment absolutely becomes very important, because right now we're using a random variable for the CPU and we're defining the range there. So that means that we'll never encounter a case with the CPU where the player position is wrong because we defined that range to the CPU. Now, if a player is playing, that is not valid on the player. So either you can check it on valid position, or you can quickly check it, add another check here, right? And then also give a prompt. So right now we do just doing a position taken thing. If you want, you can also keep another check of the range and then mention that, your your position is out of range. Can you please enter a range between 1 to 9? Very simple. See, these simple, easy checks would actually give your code, would actually help you write a better code and take care of those corner cases, right? So again, we check it was a valid position or not. If it was not a valid position, it goes into a while loop because it'll keep prompting the user to give it a valid input if it's not entering in a position which is not already taken. Does that make sense, everyone? So we again ask for an input from the user through an extent. We again ask, we'll keep on running in this loop until we have a valid position. As soon as we do have a valid position, we come out of that loop. And now we are placing the piece on the board. Use the switch case on this place piece function, right? So I hope that this all makes sense now. Now, right now, this particular segment should be clear. So you see, with these 3 lines of code, because we used functions, we actually defined different functionalities and different features in different segments. What it did for us is we have a simple code here in our play tic-tac-toe function, and the entire chunk of the placing the piece, the checking if it's a valid position or not, anything that we want to do as functionality is happening elsewhere, right? So awesome. So again, okay, so I think I see that there is a question regarding integer. So for example, if you're using an integer in Java, that's a class, not an int. I'll solve this wrong. So not an int I, you cannot do that. If you are doing an integer, say integer I, and you're defining it as a new integer, this basically means that you're defining an object from a class. This can be null. So this is another thing that you can do. I'll just remove this from now from my code, but I hope that this answers the question, that the discussion that has been happening in the comment section. All right. If you are still behind, let me know what you missed, and then I'll guide you through it all over again. All right, cool, everyone. So quick hydration break. Grab your oils, grab something to drink or grab something to eat if you haven't yet, and make sure that you stay hydrated because we are actually working on another segment of the code, and then we move on to the next part where we fix the issue that we saw that was wrong with the code. And once we are through with that, we will see how this code runs one more time, and then I want you all to try it for your own self. So I want you all to actually try out this code, and then make a submission. Then you can obviously play around with it and try out something, different. Explore with the code, explore what is missing from the code, what else you can add. If there's another functionality that you wanted to add, right now we're just using the console to make this happen. You can obviously implement this in another application of yours, or probably a website that you're trying to create. Speaking of which, we also have Hue Hacks this weekend, if you are not aware of that. So I'm coaching on Hue Hacks, so I'll see you around there as well. Hue Hacks this weekend is the hosted by MLH event that we are organizing this weekend. I'm sure that you've seen the posters around, and if you've not registered for that, I'm sure I'm going to see you there. So in Hue Hacks, it's all about creating vibrant, versatile hacks, which can be diverse and inclusive. So if you are building anything, I mean, games are something which connects everyone, right? So whatever you're trying to build, you can obviously implement this game and integrate it to your own code base on whatever project that you're trying to get as an additional functionality, and it'll just enhance your project altogether. So I'll see you all on Hue Hacks, and I'm trying to give you a little bit of ideas on how to do that. All right, so we do have a question on how to make submissions. In order to make a submission, I suppose you're asking that in reference to the March challenges. So in order to make a submission, the link is there on Discord, but I'll also post it in the chat. So once you're through with the code that we are doing right now, just head over to mlhmarchchallenges.devpost.com and show us what you built today. Show us your code base, show us what you tried to implement, and we'll be happy to see all those wonderful creations that you've made. So, all right. As I was saying, quick water break, and then we'll move on to the final segment where we'll check if we actually won the game or not, because that is also an important part that we have to do right now. All right, friends. Cool, cool, awesome. So everyone, all of you are refreshed. All of you, I'll give you another 30 seconds per se. Yeah, I think that would be enough for you all. If not, just take as much time as you need. Ask questions when you are back. I love interacting with you all up on stream, because I mean, that's the favorite part of the stream. Even though we are not in a physical event per se, these streams actually, and the comment section actually makes it easier for us to interact with you, and see where are you stuck. Because if you're stuck at some place, I won't be able to notice that, until unless you ask a question in the comment section. So if you are stuck at any one of this technical challenge, I mean, even if you find this easy and you are there for tomorrow's technical challenge, or you're there for another any other stream per se, if you're learning at Local Hack Day Build as well, any other stream that you're a part of, do ask questions for friends. Do interact with the speaker, because after that it'll make you a lot, it'll give you a clear picture of what is going on there. If you miss something, if you are confused about something, and then when you try it, it'll make a lot more sense for you. So it'll help you increase your skill set. And these streams, I believe, is an incredible way for you to learn something new every day. So just think about this. In an hour and a half per se, we actually created a tic-tac-toe game, and I for one think that's super, super amazing and awesome. So everyone, if you're following along right now, and if you're joining in just now, don't worry at all. Just register at hackp.ac/March challenges. The stroller should be, like, the ticker should be there at the bottom of, the banners that should be there at the bottom of the stream. You can see that you have to check in on hackp.ac/March challenges if you haven't yet, and also registered at tic-tac-toe. The link is hackp.ac/tic-tac-toe. If you also want, show off your skills, whatever that you've learned today, and tweet using @MLHacks. You can also tag me by @SashraKaur, and I would love to see your posts and retweet them and see what you've created this weekend. The hashtag that we use here. So if you're joining us for the first time, I mean, the one who joined me on the Local Hack Day Build streams, they already know this. They're in on the secret, but I'll let you in as well today. So what we do is we use the hashtag challenge accepted. This is an incredible hashtag that we have created in order to keep the community together. So whatever interesting thing that you create, so you're part of this entire fam, so just use the hashtag challenge accepted, and everyone can see all the interesting things that we create today. We did Adventures of Perry the last time. We did the Chrome Dino challenge the last time. We have a lot of fun with this particular hashtag, but this is the generic hashtag that we use in order to keep ourselves connected and be together and see what interesting things we're creating right now. So tweet with @MLHacks challenge accepted, and you can also tag me. I'll shortly retweet it for you. So if you are creating this tic-tac-toe game, just play it around and make a tweet, and we'd love to see it. All right. So now that we are through with this entire segment, let's move on to the final part. I hope you all are refreshed. I hope you all are, getting settled for this another part of the code. So right now we worked on the code where, the player played a position, the CPU played a position. So where we're currently at is we've actually checked that, if it's a valid position or not. We have actually placed the piece on the board. We have prompted the user to tell us which position they want to place their piece at. They're playing an X piece, so where they want to place that X piece at. We have prompted the CPU to select a random number and then place a 0 piece at. So whenever any turn happens, like whenever any piece is played, we have to check if it means the game ended or not. It means that someone won or not. In order to do that, all we need to do is what? Implement another check win function, right? We'll talk about the check win function and how to implement that. But in the main code, now you get it, right? In the main code, all you need to do is implement this check win function. So this string result actually stores as a result, and the check win function is something that we'll write. So just keep it on your to-do. In your main function, write string result and then add a check win. And whatever you want to do with that, you could process that later and keep a check on it. But for now, the only thing that you need to focus on is this only one statement, which is the check win function. So whatever you're creating, how you're making it, in order to, in order to keep a check on this, we need to implement the check when function and add that functionality to our code to see if it's done or not, right? So before we move on to the check when function, the other thing that we need to take care of, we need to keep repeating all of these actions, right? We need to keep repeating these actions. So what I did here and this marks actually the end of our play tic-tac-toe function, because then we'll just focus on the check when segment, is that we added into a while loop. And for now, I just gave it a while true, and I break whenever I have my answer with me. But if not, you can obviously try out something different. You can obviously take a different condition here. So for now, just a while true and keep this entire segment in while loop. So unless someone wins or the board is filled, it'll keep on moving. It'll keep on, asking for another integer, another position from the CPU or the user, and turn by turn, go on playing with that. So you can see that this is the entire segment, but for now, let's focus on the check when function. So before we move on to the check when function, everyone, I hope that this particular segment is clear. I hope that you're following along. I hope that, this entire thing was not too confusing for you. So it was very simple thing that we did was to create, the very simple thing that we did was to just add it in a while loop, and let's just keep on looping until we have an answer. How do we check that we found an answer or not? That's what we're going to achieve in the check when function, right? All right, everyone. So for the check when function, what we need is, again, I'm going to use array as a list in order to keep it simple, because arrays is something very basic. So whenever you start with a programming language, you learn about arrays. But if you've not, but if you are an experienced programmer, you might know that you can use a hash set here, or another, right now we're just using lists, but of course you can use hash sets, you can use hash maps, you can use matrices, you can use anything that you want to in order to reiterate this code and lower the complexity. Again, there's another thing that we can do here, but let's talk about creating a basic condition first, and then we'll move on to the next part, right? 1 second. Oh. Awesome. Yes, of course. So now that we're ready, let's move on to the next section where we are going to implement the check when function. So for now, we want the winning conditions, right? So what are the winning conditions? Let's quickly state the winning conditions first. Everyone, so this is what your matrix looks like, right? Forget about the code for a minute. Let's talk about the logic here. Right? This is what your matrix looks like. Everyone, following along, I want everyone to just mention, talk to me in the comment section. Whatever I'm asking, I want you to be interactive so that I know that you get it. So what are the winning conditions? The rows, the columns, and the diagonals. That means that if someone placed the same element at row 1, or the same element at row 2, or the same element at row 3, and same thing for columns or diagonals, that means that person wins. So the winning conditions would be what? 1, 2, and 3. 4, 5, and 6, 7, 8, and 9. Correct? Absolutely. Now, if they win by column, if they're the same elements in the columns, that means that 1, 4, and 7 is the winning condition. Then let's say 2, 5, and 6 is the winning condition. And then 2, 5, and 8 is the winning condition. Sorry. And then 3, 6, and 9 is also a winning condition. Right? So we have done the rows, we've done the columns. What else is left? The diagonals, which means that 1, 5, and 7 is also a winning condition, and 3, 5, and 7 is also a winning condition, right? Or 1, 5, and 9, and 3, 5, and 7. So everyone, these are the winning conditions, right? Following along. Let me come back to the comment section and see that. Cool. All right. Wonderful. Glad to see it. Okay. Yes. Incredible. So these are the winning conditions. Practically easy. So we want to implement that. So we'll do that in the form of another list that we want to do, that we want to create. So we'll create a list integer, and we want an array as a list. So the row 1, the first condition, which was 1, 2, 3, 4, 5, 6, and 7, 8, 9. Can you see it here? 1, 2, 3, 4, 5, 6, 7, and 9. Basically, I'm creating an integer list of row 1, row 2, row 3, column 1, column 2, column 3, diagonal 1, and diagonal 2. And I've added all of these conditions that we just listed to it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then as you can see that we had 1, 4, 7 as a column. Here you can see 1, 4, 7. Then you can also see 258. You can see 258 here. Then you can also see C69. You can see 369 here. The final two diagonal conditions, which is 159 and 357, you can see them here as well. Right. So as you can see that what we did here was just very easily we implemented all those winning conditions and we added them as a list, created an integer list out of it, and gave a name to all those lists. Now we want a list of lists, which is like will contain all these lists. So for row 1, row 2, column row 3, column 1, column 2, column 3, and diagonal 1, diagonal 2, what we did was we just created a list of wins and we added all these different conditions into our wins list. So a list of list is basically what will add all of these conditions into another list. So what it looks like right now is 1, 2, 3. Then we have another one, which is 4, 5, 6, and so on, right? So say 4, 5, 6, 7, 8, 9, 1, 4, 7, 2, 5, 8. So this is a list of lists which we created here. So why did we do it, right? So what we did was, again, you can use a hash set and you can use different, you can make a code out of it where you have like 1 hash, 2 hash, 3 to ensure that, it's something which you can just check and run a contains key function if you're implementing a hash map. So whatever you want to do, you can try out a different thing. Sorry about that. Yeah, you can try out a different thing and then you can implement it. Right. So in order to do that, now that we have our winning conditions in place, I hope that this segment is clear. We have our winning conditions in place. What we need to do is at every step of the point, we want to check if any one of the winning condition is satisfied or not. Right? Simple, very easy. We want to check if any one of the winning conditions are satisfied. How should we do that? So this is the code which will check if the winning conditions are satisfied or not. Now we want to be able to actually tell if the winning condition is satisfied or not. And so we create a string, an empty string, and we just basically reinitialize, return another string of if we won, we say congratulations, you won. If the CPU won, we'll just say better luck next time. Or we have to tell the condition if it's a tie, right? So what we'll do is we'll grab each list in the wins. Wins is a list of a list, right? List of integers. So we'll grab each list in the wins array list and we'll check if any one of the condition is satisfied, which means that if the player position contains all elements of L. So again, this is a very important segment because what we're trying to achieve here is the player positions was an array list. The list is also basically the player positions an array list which extends list, and we also have implemented another list for wins. So when we're trying to connect those two, again, another important thing that we are trying to use here is the collections class. Right. So how are we using the collections class? If you click on this list, you can see that it extends collection, right? And what happens here is the collections class actually works like sets. If you've heard of sets, this is something that you might know. So in sets, if we want to check if all the elements of a particular set is equal to another set, we use the we can see if all the elements of a particular set is present in a different context. We just say that it's the same or all the elements are there, and we can use that. So collection is based on that sets segment or the sets function, the fundamentals of sets. And right now, if you're using that collections class, this contains all function. What it does is it checks if all the elements of L are available in pair positions. Let me explain it better with an example, right? So let's say the player played a position 1, 2, let's say they played 4, and they played 3, right? And first the player played 1, the CPU played, let's say, 9. Then the player played 2, the CPU played 5. Then the player played 4, and the CPU, let's say, played 6, and the player played 3. And that's how you know that player won. Why the player won? Because they have 1, 2, and 3, right? So what it looks like right now, what it should look like is this is what player position looks like. And this is what CPU positions look like. Right? So the player positions are 1, 2, 4, and 3, and 9, 5, and 6. So when we are traversing through the list of wins, you can see that 1, 2, 3 is there as a present as a list, right? So if, which is in list L, of course. So L is what? Right now, the first one, which is 1, 2, 3. So as you can see, L is 1, 2, 3, and the player position is 1, 2, 4, and 3. So it will check if player position contains all the elements of L, which is 1, 2, 4, 3 contains all 1, 2, 3, which means that if 1, 2, 3, all of them are present in player positions, which is true, then that means congratulations, you won. And that is the same way it works for the player positions. I hope that this particular segment is clear because I was trying to explain it in a better way. I'm not sure if the message was delivered, but I hope that it is. So I wanted to explain to you how these sets work, how collections class work, and also how you can check, use the contains all function to see if it's actually working or not. If you have any questions, feel free to ask them. But for now, let's move on because we saw that how player positions work, how CPU positions work, and how you can, return statements. Now, what about a tie? Let's say if there is a tie, which means that there are no more positions left to play. All the matrix is entirely filled, and which means that nobody won, right? So else if the player position, so if the player position contains all L, CPU position contains all L, that means CPU one. The player position contains all L, which means player one. If the matrix is filled, then that means it's a tie. So to check that, we'll just check the size of the array list. If the player position size and CPU position size, when you sum both of them, which it has all the 9 elements present, the 9 positions where you can place a piece, then it's a tie, right? Everyone, I hope that this piece of code is absolutely clear because now we also work on fixing a problem that we encountered. I'll explain the problem once more in order to, help you out here a bit. All right, so we want to result this in a die, but we have to make sure that it's, we can see the problem. So let's see. 5, 7. So I'm playing the game and I want to result it in a tie in order to see that I'm covering all the edge cases or not. Right. So let's say I place it on 6. Right. Now, as you can see that I am about to win. Right. Everyone following along. Mention that in the comment section if you understand it up until this point, because now I'm going to press 3 and then it should result in, the fact that I won, which it's not doing. So it says that it's a tie, which is wrong because clearly 3, 5, and 7 is present and I won. So what is going wrong here? So there is something which is wrong here in this particular segment of the code. I told you that I figured it out, but I'm not sure if you did. So I want to give you a chance to figure out what is wrong with this piece of code, and then we can move forward. Or don't worry, I'll tell you what is wrong. I'll explain what is wrong, and then we can fix this issue as well. This is where we're debugging the code in order to see if what is working and what's not. So anyone, what is the one thing that is wrong with this segment, which is creating that problem? Because as you can see, it's not that every time that I win or the player wins, it's telling you that, it's a tie. The only moment that it's telling you it's a tie is when the table is filled and it's the last position. Yes, of course, I'll show you the output once again. Okay. Right. So as you can see, we tried out with 5. We placed it here. We tried out with 7. We placed it here. CPU is running its chance. Then we tried out with 9. We placed it here. We're trying not to win, but at the end moment, we just absolutely won. It still says that it's a tie. So why do you think that this has happened? It's a very interesting thing because when I was writing down this code, I also didn't notice that. But as soon as I encountered this problem, I realized, oh, I see, this is wrong. This is what's wrong with the particular code. Why do you think the code is not working? Do you want to see the code again? Yes, but can you please be a little more specific? Oops, sorry. Can you please be a little more specific? Because, the size 9 is absolutely necessary. So the size 9 actually check if it's a tie or not. Let's say if it was actually a tie, then we already need that segment where it says it. We already need that statement where it says that it's a tie, right? It's just happening that whenever we check for the last scenario, it's saying it's a tie. It's not checking for the win conditions. Let's see the code again, shall we? All right. So now think about this. What is happening is it's a for loop. So that means that it's running each condition one by one, right? So it'll check the first win condition, then it should check the second win condition, then the third win condition. Let's say if you won at the final position, right? Or let's say that you won somewhere in between where the entire matrix is not fit. So let's say your matrix looks something like, let's just copy that. Right. Okay. So let's say your matrix right now looks something like this. Let's say that this was not the scenario. This was the case, right? Then that means we won, right? And I'll check the player position and I'll see it won, because for this particular case, what it'll do is it'll come here to check for the wins. The winning condition is what? 1, 5, and 7, right? So what is we can fix it by keeping it a tie first. I'm not sure if that'll work, and I'll tell you why it will not work. Because if you keep the running condition, the tie first, the CPU position and the player position size first, then what will happen is, even if the player won, you already told them that the matrix is filled, it's a tie. It'll result in the same problem. Then in that scenario, you'll not even get that answer that we're getting right now, which is that in one particular case, it says that the player won. I'll explain why is it happening this way. So let's say that this was your case scenario at the end, and the check win function is running right now, right? So the winning condition for this is 1, 5, 7, and your player position should also contain 6 per se and 9, right? This is what your player positions would look like. Your CPU positions in this scenario would look like 2, 4, and 8, but let's just ignore that for a moment, right? So it'll come to the list of wins. It'll check if the player position contains L, which it will not, because right now what L is at 1, 3, and 5. Let's just copy this second. So let's just bring it back here, explain that. Right. So this is what your wins would look like. Right. So when you're traversing through the list, it's going one by one. Am I correct? Yes. So the first thing that it'll experience is 1, 2, 3. The next it'll check 4, 5, 6. Then it'll check 7, 8, 9, 1, 4, 7, and so on. Right. So as you can see, this is what your list would look like. But for now, the winning condition is 1, 5, and 7. So first, the L is at 1, 2, and 3. It'll check 1, 2, and 3 is present. It's not. So it'll go and check if 1, 2, 3 is present in the CPU position. It'll not find that. Then it'll check if the player positions and the CPU positions is equal to 9. It will not find that, right? It's not. So it'll not go into either the if loop or the else loop or the else loop. So it'll go on to the next list. Right. Bear with me for a second. This would be an aha moment in just a bit, because you'll understand what's wrong with the code. So the 4, 5, it'll go to the next segment, which is 4, 5, 6. Then it'll keep the same check and not go into either if or else statement for 4, 5, 6. The only moment it'll go into an if statement would be when player position contains on L, which is in the case of 1, 5, and 7. 1, 5, and 9, sorry. 1, 5, and 9. Yeah. So, and when it reaches this particular diagonal case, 1, 5, and 9, when L is 1, 5, and 9, that is when it'll tell you that congratulations, you won. Now let's come back to the example that the issue that we are facing with the example, right? So let's use this as an example. Again, reiterate this with me. It'll take a little while, but it'll give you a lot of debugging skills, and it'll help you a lot when you're debugging your code as well. So the player positions. What does it look like? The player positions look like for this. The player positions for this case would be 3, 5. Everyone, you following along? 3, 5, 6, 7, and 9. Correct? So what would, and let's say the CPU positions look like? One, 2, 4, and 8. Right? So L. Let's see what the L is at first. So this is what your L is. So right now, this is your L. Everyone following along, this I hope that this particular section is clear. So 1, 2, 4, and 8 is player position, then 3, 5, 6, 7, and 9 is. So this is your L. What it'll do is it'll check if 1, 2, and 3 is present in either player positions. It's not. CPU positions, it's not. So again, see the code again. If player position contains all L, L is 1, 2, 3. Does it contain all L? It does not. So it will not go in this particular if statement. Then for the else if, its CPU position contains all L, which is another L. So CPU positions is 1, 2, 4, and 8. So it does not contain all L, which is 1, 2, 3. 3 is missing. It will not go into else if loop. Then the other loop, which is else if player position size and CPU position size equals 9. When you total it, player positions is the size of player positions is 5. And the size of CPU position is 4, right? 5 plus 4 is 9. That means it satisfies the statement. It'll go inside the loop, and what it'll do is it'll return its tie, right? So right now it says, see what happened here is it wasn't a tie, but it still returned a tie because we actually returned it right from here and we did not check any conditions. Any of the other winning conditions were not checked. Everyone, are you following along? Did you get that? So the easiest way that we can fix this problem is just we resulted in it's a tie, and if we get a winning condition, we actually return the winning condition. But if it's a tie, it'll only check all the winning conditions and only then it'll return a tie. It was that easy to fix this problem. But I hope that you get how we debugged it and how we found out. Everyone, if you are still confused about this segment, let me know. I will repeat the problem and I'll show you how it's fixed. So meanwhile, let's try it again one more time, shall we? So the check condition before verdict. Yes, so actually what it was doing here, it was returning that it's a tie even before checking any other condition. So what we need to do is, we need to actually store that it might be a tie. We need to store that it's a tie. It'll only return it's a tie if the player position and the CPU position size is 9 and it is at no point in time the CPU 1 or the player 1. Right? You can also change this itself condition and add another condition. So basically this is what we want to achieve. The way that you achieve it can be different. So you can also add a condition here instead of storing it in result. You can add a condition here which says player position does not contain all or CPU position does not contain all LM. So at any point, it's not, if you want to try that, but you want to add another checks to it. And that would be a tedious task because then you have to think about that it should not be for that particular list. It should move on to the next list. So this is a very easy way in which you can implement that. All right, very simple, very easy. But all you need to do is store it's a tie. And the reason, now you'll ask that why I'm not adding it's a tie here instead. The reason that I'm not doing that is not all the time. It's not necessary that the player position size is 9. We're checking it in middle as well. It's not like even when the whole matrix is filled is when you decide you win or not. You are checking it at each play when each piece is played. So it needs to be blank in that sense. All right, of course, I will repeat it. So I will repeat it, but I want you to be very interactive with me this time because then I'll understand which point you're not understanding and I can focus on that first, right? Let's talk about this again. Okay, so I hope this part is clear where the player positions is 3, 5, 6, 7, and 9, and the CPU positions is 1, 2, 4, and 8. Chat room, is that correct? So the player position is 3, 5, 6, and 9, 6, 7, and 9, and the CPU position is 1, 4, 7, 1, 4, and 8, right? So this particular segment where you can see, yeah, so this particular area of code where this particular comment basically, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 4, 7 is there, right? Absolutely. So this is your list. This is what your list look like. Winning conditions look like this. So what L is doing is it's a for loop list of L in all the wins. So this is what your wins look like. And we'll traversing each of them and checking each of the winning conditions, correct? So we'll go to the first condition. We'll see that 1, 2, 3 is there. Is 1, 2, 3 present? So the condition that we've added in our code is player position contains all L, right? So we'll see that just the player position contains all L, and we also check that for the CPU position. So coming back up here, The player positions, does it contain all L? No, it does not, right? The player position has 3, but it does not have like 2 or 1, right, everyone? So the player position does not contain L. Then it will not go inside that if statement. What I can do more is, let me just, no, zoom out. Let me know if things are still visible because I want to zoom out and have the code as well in the screen. Right? I hope that this is still visible to you all and it's fine, right? All right. So if it's not visible, let me know. I want you to see the code as well. So you can see that it will check the player positions contains all L. Does the player position contain all L? L is 1, 2, 3. Does the player position contain 3, 5, 6, 7, and 9? It does not. So 1, 2 are still missing from the player position, which means that it's not a winning conditions. So it will not go inside the if statement, right? So it'll check CPU conditions positions next. So CPU position is 1, 2, 4, and 8. Yeah, basically if 1, 2, 4, 1, 2, 3 is present in 1, 2, 4, and 8, no, they're not. So contains all L. L is 1, 2, and 3. CPU position is 1, 2, 4, and 8. Do you see the same elements in L and CPU positions? You do not, because 3 is missing, right? So basically player position does not have 1 and 2. CPU position does not have 3, which means that this is not a winning condition. And right now, nobody won. Now, our code looked, before we did this, our code looked something like this. Return, it's a tie, right? What happened here is, if player position's size and CPU position size is 9, you sum it. So player position is 5, CPU position is 4, 5 plus 4 would be 9. So it'll satisfy this condition and it'll straight away return it's a tie without even checking any of these conditions to see if our CPU won or not. You can clearly see that the player won, right? How you can see that? Because it satisfied this condition. It has 3, it has 5, and it has 7. So this is the condition at which it'll win. But because the L did not get a chance to move to the next iteration and it was returned it's a tie at the first segment, it never found out if 3, 5, 7 was a winning condition or not. Everyone, did you follow along? Did you get this? Anubhav, Rudrashish, Mohit, are you still stuck here? Or like, is this the moment where you say, oh yes, I got it. All right, I understand. Oh, awesome. So it never moves on to the next condition, right? It's not checking for 4, 5, 6, 7, 8, 9, 1, 4, 7, and anything else. So the only reason that this is happening is because the matrix was filled and it actually took a problem. It took that. So we just add res equals to it's a tie because we'll store that it might be a tie. It's a tie, we'll store that result because it might be a tie, it might not be a tie. If it's not a tie, then we certainly know for sure that somebody won because we're checking it at each segment. We're checking it when player plays a piece, we're checking it when CPU plays a piece. So there'll never be a scenario when both the player or the CPU won because we're checking it after each chance, right? So I'll show you where we're checking it after each chance, but this is what it's how it's working. So just storing it's a tie, it'll check all the positions. How storing it fix the problem? Because right now it'll just store that it's a tie. It'll not return anything. So basically L moves on to this. Now L is this. I'll check again. It'll not find anything. It'll again store it's a tie. Then again it's an L. It'll again store it's a tie. And so on and so forth till the point it reaches 1, 5, 3, 5, and 7, I think. Yeah. 3, 5, and 7. When it reaches here, then it'll check if all contains player positions and it will. Player position contains all the elements of L, and that is when it returns. Congratulations, you won. All right. So why don't we try this out? Okay. The small, it's like a very small change that we made, but let's try this out once again, one more time. We'll try to win, but at the last moment, basically. Right? 5, 3, I can't based on 3, 1. Okay, let's say we don't want the CPU to win as well. So 6. Okay, what about 8. Wow. So absolutely. Now it should say that, congratulations, you won. Let's try that out. So 4. Congratulations, you won. So yes, we absolutely fixed the problem. And this is how we did it. Because right now, it'll keep on checking all the winning conditions up until it finds one. If it does not find one, only then it will return it's a tie. Right? Everyone, following along. So we built the tic-tac-toe game and we also worked through it. Okay. So this is what your code looks like. I hope this part is clear. I'll just remove this. Okay. Everyone, got it? Everyone, this is clear. I hope that it is. Let's move on to the back to the main function and see what we missed. So I hope that the check when function altogether is clear. This is the check when function. This is the print place piece function. Very simple. We did it in 3 functions separately and we placed a piece on the board. So we are using the place piece, we are checking our result, we get our result. Now, if the result length is greater than 0, which means that we actually found something, either it's a tie or congratulations, you won, or any other thing. So if we found a string, then that means we'll print the board, which is our final result. We'll print the result and we'll break from the loop. Remember that it was a while true loop. So when in order to escape from the while loop, you actually have to break out of the loop. So this code, I hope that this one is clear. The only thing that we are checking here if it's the result length was 0 or not. Because if the result length is 0, it'll never go into any one of these if else statements, and it'll come out with the result, which is just a blank string. And if the result is a blank string, then that means that our work is still not complete. We don't have to print the answer. We don't have to print the board. We don't have to do anything. We have to ask the CPU to play. And the same result check function is also running here. The only thing that is not happening here is printing the board. So we're not printing the board when the CPU wins. You can also print it, like it doesn't matter. I just removed it because then I was already printing the board at the end of each chance. Right? It'll just be redundant. That's the reason that I removed it. All right. So I hope that these 3 functions are absolutely clear to you all. Any questions up until this section? Because now we'll move on to the main function, and that is when we can just put all those pieces together and see what we actually created right now. Yes, I can show the output for the die. Absolutely. Let's try it again. Everyone, let's try it again. So this is the fun part. We play the game one more time, the game that we created. So tell me the numbers and I will input it for you. So let's start with 5. And now we want to result in a tie. Should we go for 3? Yes, 3. Now we want it to be a tie. Let's say we go for 4. Let's go for 7. Absolutely. Oh, sorry, I won. Let's try again. We're trying to result in a tie. Okay. 3. Let's say we go for an 8. Oh, I won again. Try again. Okay. Let's see. 6. Don't worry, we'll do this. 1, 7, 2. Oops. Try again. One more time. 6, 8, 1. 7. Should we go for 7? CPU 1. CPU is very smart. CPU actually, we won. CPU is not playing smart at all, is the fact. Let's try again. No worries. We'll make this happen. 1. We want to result it in a tie. I think we should go for 7 maybe. Then let's go for a 3. Yeah, absolutely. So now, as you can see that this will result in a tie. 5. Okay. Oh, sorry. Congratulations. It did not result in a tie. We won by the diagonal. Come on, one more time. I think I am failing at this. I'm failing horribly at this. I mean, it's just, I'm winning all the time. So if you want to take a pick. All right, starting now. Gaurav, let's start with 5. What next? You want me to go for 2? Or 1 maybe? No, 1 is already filled. 7 maybe. Let's try with that. Then let's try with 8. Then let's try with 6. 1 again. Oh God, it's It's so tough to get a tie at this point. 2, 4. I'll call myself a tic-tac-toe pro because of this now. Okay, 1. I hope that this is it. Oh, the CPU one. She's much more. Okay. Sorry. That was an input mismatch exception. So this is where we actually need to check for the range, right? The one that we mentioned. Let's try again. 3. Okay. What next? Should we go for a 7? Should we go for a 1? Okay. Let's try. I mean, I think I'm going to win again. 5, 7, 8. Pick one. 6. Review 1. Need it high. Come on. 3. Okay. 5. Okay, no. Again, V1. Oh god. 2. No feeling. That is no. Who needs a tie anyway? Do we actually need it? Oh my goodness. 7. Okay, we won it again. Oh, we won again. We actually need it. Do you want, like, we have to, like, make it happen. So help me out here, because I don't think we can make that tie happen. It's really, really difficult to make that happen. See? Let's start with 1. Let's go with 5. No, I'll not go with 5. Let's go with 4. Let's go with 2. Let's go with 9. I just hope that CPU picks 5. No, again, V1. Even if I hope it's not going to change anything. Okay, let's start with 9 this time. 9. 6. Now we're just playing it for the fun of it. I mean, I don't think that we're playing it to actually debug something or actually check on the code. Now we're just playing for fun. Okay, 1. Did we actually do it? Like, no. Let's try with 1 again. Okay, 1. Go for it. Take your pick. 2. Okay. 7. Okay. 8 is already filled. I'm gonna go for 6. Okay. Let's go for 5. It's a tie. We did it. I mean, I'm not so proud. I'm not so proud of the code at this particular point of time. I'm proud that I resulted in a tie. This was tough, friends. This was tough, but we did it. Yes. I mean, this is the moment where I will take a screenshot because we resulted in a tie, and I would actually tweet this part because this is the difficult segment of it, right? Yes, we won. Okay, we resulted in a tie, and we did it. Absolutely. Awesome. So, I mean, I'm not sure. I think Drushish asked, thank you for this very, very difficult challenge. I mean, March challenges are not challenges. I mean, Sashtraka's challenges are definitely not challenges if there's not a twist involved. And the twist was to get a tie in this game, which we actually did. I mean, people play for the win, but we are playing for the tie. I mean, that's totally fine, but we did it. All right. So, yes. I mean, I can see the chat room is already very, very happy, super delighted to see it. Awesome. So, again, coming back to the code, coming back to the task at hand, we resulted in a tie. We played this game, and this is, I mean, just to give you an entire code review, what's happening in the main function to give you a gist of how this works. So what we do is we're just running this entire segment again and again. So we're using a do while loop, where the player positions and the CPU positions is, being made into an array list. We run the play tic-tac-toe game and we ask if you want to play again or not as soon as the game is over. If you want to play again, if we enter a yes, it breaks out of the loop. And if not, it'll just keep on continue playing. Very simple piece of code. I'm sure that this does not sound too tough for you. I hope it does not. If you have any questions, you can ask them for this section, but I mean, this is what it looks like. Now, on to something more interesting that I wanted to discuss with you. As you can see in the check win function, what is happening is we're always creating the win list again and again. So as you can see, this list always this list can basically be either a static list or creating it once in the main function should be enough. So you can send it as an argument. You can make it a static list if you want to, because right now in the check-in function, this segment is being run is created again and again whenever you run a check-in function and you play the tic-tac-toe game again. So you might want to grab this piece of code out. So as you can see, I explained to you how you can break this into pieces of code and create chunks out of it. So this is another exercise that I want you to do. The code is also available on my GitHub profile if you want to have a look at it. I hope that it is. I actually didn't. Yeah, so it should be. So once you see, this code is actually available on the GitHub profile if you want to have a look at it. But I want you to remember all the tweaks that we made. I want you to remember what all changes we talked about when we were going through the code base, and make those changes happen. See where you can include and remove that. Remove a particular piece of code and create a different function out of it, because that will help you. So there's one absolutely brilliant tip that someone gave me, and it I think should be helpful for you too, is that make use of the solid principles that you've learned. That's a single functionality class. So class should either implement one single function, and that same applies for your functions and your arguments. So whenever you're trying to implement a particular feature, make sure that you break your entire piece into different chunks, and then use that code so that your code is reusable. You can go ahead and use it again and again. Now, if I was writing the place piece code in the main function, think about it this way. I had to repeat it and write it again for the CPU and the player. The reason that it's working so perfectly right now is that I made a generic function and I'm using it again and again. Now, so I think that's all. Let's remove this from the stream. Okay, so the thing that we have to do right now is absolutely right now, we'll give it a minute. I want you all to go ahead and make a submission to the March challenges. So write the code down, finish off, make the tweaks, make the changes, make it your own, and then make a submission or March challenges. I want everyone to make that submission. I want everyone to check in on hackme.ac/tic-tac-toe if you haven't already yet. And of course, we resulted in a tie. That was the achievement of the day, even though we created the tic-tac-toe game. I'm not sure if that achievement counts as big as the fact that we resulted in a tie. So make sure that you tweet your achievements with @MLHacks, #challenge accepted, and you can also tag me. I go by the name Sashrika Kaur. Let me just put up a banner here. Yes, I'm sure most of you already know me, but yes, we already did it. But if you don't know me, I go by the name Sashrika Kaur. You can find me on Twitter, and you can tag us and show off your achievements with the #challenge accepted. So once you do this, I make sure that you also make a submission on the March Challenges dev post page. Let me share that link again. You can also find it on Discord if you want to yet, but I hope that this is fine. Now, if you have any questions, please do ask them now. Let me just quickly add the March Challenges dev post link once again. There you go. So it should be in the comment section, and you have been the most incredible and wonderful audience that I've ever came across. You were very patient, and I'm super excited to see what you've learned today. I'm super excited to see what you'll create and submit on DevPost. I'll keep a look at all your registrations, all right? I know who all joined this particular stream. So make sure that you add the submission. So there's a bunch of other things that I'm sure that you would be super excited about, because I am. So we're still running March challenges up until the end of March. I'm actually not up until the end of March, but before Local Hack Day share kicks right in. So make sure that you participate. Let me tell you which all events are active tomorrow. I can do that for you. hackme.ac/March challenges. So the entire schedule is up at hackme.ac/March challenges if you want to look at it, and if you want to see what all is next or all is coming up. So today we were at day 24. Oh my goodness, I still can't believe it's day 24, and we created a tic-tac-toe game. There's also create your own digital brand via your website, social media accounts, how to install Python and not ruin your environment, and then still need to basically another session on learning a new language. So there are a bunch of other things in store for you. 3 days more worth of challenges. You can check out the schedule and register for it. Sorry, up on stream. And basically, once you are through with that, yeah, sorry. Once you are through with that, you can just go ahead. I mean, I'm a little dehydrated right now. Give me a second. Once you are through with that, and checking out the schedule and you see all the March challenges that are active, you can obviously go ahead and register for local hack day share. The schedule is up already, and there's tons of exciting streams and prizes for you all. There's awesome LHC swag. So the points that you earn for your guild would result in swag. So make sure that you join a guild and take part in all those amazing and awesome exercises that we have for you and activities that we have planned. So my name is Sashika Kaur. Make sure that you do tag me and make sure that you do register for all these events that we just mentioned. Keep learning, folks, and I will see you at Hugh Hacks for now. So thank you so much for joining in. I hope that you had a great and incredible time learning tic-tac-toe and playing the tie game with me. But I'm sure to see you around for the challenges. All right, friends. See ya. Bye.